Let's build a few more circuits. So here we're going to do the x or complement, or x plus complement of y times z. So notice that this one has 3 inputs, so we've only got 2 so far. So let's go ahead and add a third input and a third label. And this one we'll label as z. All right, so there's our 3 inputs. And now we'll do this by order of operations. So we're going to do parentheses first. So we do this first set of parentheses. And inside there we have a complement. The complement will be done first. So here's our NOT gate, and it's on y. We need NOT y right there. Okay, so we've got that one. And then we need to do an AND with X, and that's an AND is, we use an OR gate to do, so not AND. Okay, I said that wrong. We need to do X plus Y, and we do plus with an OR gate. So there we have X plus, and now it's the complement of Y. So here, I'm going to back this up a little bit, move this out a little bit so that I can get the one input is coming from the X and the other one is coming from this NOT gate there. So now we have X and not Y going into this OR gate. I'm going to turn these all off. Okay, so there I've got that first set of parentheses. Now I want to do the second set of parentheses, and that is y times z, and we do a times, a multiplication with an AND gate. So we need to get from y. Now notice how I have an output coming from y into the NOT gate, but I can have another one. I just capture it. You can get as many out of that y as you want. So this one's going into that AND gate. So there's y and z. All right, so that's the second parentheses. And now I want to multiply the first parentheses with the second parentheses, and a multiplication is an AND gate. So I'm going to get an AND gate, and I'm going to bring the result of X plus Y complement and the output of Y times Z and put that in that AND gate. Now that's the whole expression. So now I want a light bulb to tell me what my end result looks like. All right, there I've built the circuit. Now I do want to verify it, and so I did this offline where I took that same expression, X plus complement Y times Z, and I just built a table so I knew what to expect. And notice what the end result was. It was all zeros except when they're all on. So let's go see if that's what we get. So when they're all off, it's off. When Z is 1, they're off. When Y is 1 and 0 is, when Y is 1 and 0, Z is 0, it's off. When Y and Z, I'm just counting, so this is 3, it's off. And then the next thing is where X is 1 and Y is 0 and Z is 0, and it's off. Then X is 1, Y is 0, Z is 1, it's off. The next one is X1, Y1, Z0, and it's off. So far it's holding true. And then the last one is when they're all on and it's on. So it worked. It was 0, all the combinations were 0 except when we had all the switches on. What if we have 3 additions in a row without any parentheses? Well, we need to OR these, right? So we're going to need an OR gate. But OR gates only have 2 inputs, so we can't put all 3 of these into the OR gate. And so that's not an option. We certainly can do the NOT first, because by order of operations, that Y NOT will happen first. But now how do we OR 3 things together? Well, you just need to do them 2 at a time. And you can, because of the law of association, it doesn't matter, right? The associative law says it doesn't matter which order you do them in. If you've got 2 ands, you can do the first one first, or the second one, really you can put the parentheses anywhere. And so we just have to go ahead and let's just do these 2. Let's do X or Y. So we've done the first 2, and then to do the next one, Now it's going to be the output of the X or the Y right here and Z. And so there we have a series of 3 ORs, right? We have X plus Y naught plus Z. So we have 2 addition operations, and we just had to use 2 OR gates to do that. Here's another problem with 3 ands, right? X with the multiplication, X times Y naught times Z. So these are multiplication, but again, it's 2 of them together. So let's get our naught in there for our Y naught. And now we just have ands. And again, because of the associative law, it doesn't matter which order we do them in. So let's do it the other one. Let's say we've got an and gates have only 2 inputs. So we take the input from the Y naught and the Z. So now we've done Y naught times Z. Now we need to get it times X. So it's going to require another AND gate. And there we have that other AND gate. Okay, and so that really gets us the 2, make things a little bit tighter here. So that gives us really just the first term, X times Y naught times Z. And now we have an XY. This is another AND gate. And we're going to get crossovers here. So we just have to be careful that we get the crossovers, make them as clear as we can. This is coming directly from X and directly from Y. It doesn't go through the NOT gate, right? Because it's X times Y. So now we've got that, and now we want to OR them together. And we OR them together, the output of those 2, and then it goes into the light bulb. And then we can do that expression. Now we may get expressions that are more complex. So notice that this one has 2 ands, X times Y naught times Z, so 2 multiplications, and it has 2 additions. And that's okay. You just work through them one at a time, right? You just, again, do order of operations and just work through them together. So there we have the Y naught. Now we're going to multiply. So, and just to show that it works out exactly the same, let's do it the other way. We have X times Y, so X and Y naught. And then we do the other AND to get that Z in there. So this is the output of the X times Y naught. We take that output from X times Y naught and multiply it by Z. And so that gives us that's just the first term. Then we do the second term where we have X and Y. And then we do the third term, which is Y times Z. And there's Y times Z. And now we have this problem where we need to use OR gates with 3 outputs, and we can't do that, right? Because OR gates only have 2 inputs. So we just take an OR gate, and again, it doesn't matter what order because of the associative law. You can do these in any order. So here this is the second term ORed with the third term. So we've done the second term, X times Y, ORed with Y times Z. And now we need to get that first term in there. And again, it's with an OR. So that's that OR. I'm going to move this light bulb over a bit. We're getting it long out here. So put the OR in there, and then this is the OR from the second 2 terms. And now we've got those 3 done. So notice that we just did 2 initially, and then we ORed it with the third term. And then that's how we're done. So you can get these complex and really represent these expressions just by combining them. And again, pay really close attention to the order that you do that in. It makes a difference.